Another common technique for transforming numeric data is mathematical transformation. This usually involves creating new variables out of existing variables through mathematical formulas. Sometimes this can help bring information out of data, making analytics more fruitful. For example, body mass index or BMI, which is calculated as weight in kilograms divided by squared height in meters, is usually a better predictor of diabetes risk than weight or height alone. Another situation where mathematical transformation is useful is to deal with skewed variables. The extremely high or low values of skewed variables can significantly inflate or deflate the average of the entire dataset, making it difficult to detect any meaningful relationships. Therefore, it is often recommended that logarithm transformation or square root transformation be used to make the variable less skewed. Other mathematical transformations include converting values into percentages, differences, or beta values in order to meet various needs of the analysis. Dealing with calendar dates can be tricky sometimes in data analysis. Most software will store date values as numbers in order to enable calculation and comparison. For example, in R, date is stored as the number of days since January 1st, 1970, and uses negative numbers for earlier dates. Calculating age from a person's birth date or finding a time duration between two dates are usually some of the common ways to transform and enrich your data. We are going to perform some further transformation of the customer's data set in the next demonstration. We will compute the percentage difference between the customer's purchases in 2017 and 2018. Then perform a logarithm transformation on income to reduce data skewness. And finally, we are going to perform calculation on date values. In this demonstration, I'm going to show you how to perform mathematical transformations using R. Here we are going to accomplish a few tasks. First, we are going to create two new variables to capture the difference and the percentage difference between a customer's 2017 and 2018 spending, because they may be more useful in understanding the customer's spending pattern. And second, we also notice that the income variable is highly skewed, with most customers' income falling between $40,000 and $100,000, with only a few very high income earners in the dataset. So we are going to perform the natural logarithm transformation in order to reduce the skewness of the data. And then we are going to work with some calendar date values in the dataset. We are going to first convert customer birthdays into age as of January 1st, 2019, because age would be more useful in analysis. And then we are going to create a new variable that captures the birth month of the customer. In RStudio, I have imported a customer's dataset as a data frame called My Data. We are going to find the spending difference and then use the head function to view the first few observations. To calculate the spending difference, we are going to subtract the customer's spending in 2017 from the customer's spending in 2018. I'm going to create a new script and create a new variable called spending difference. and run it. And then let's take a look at the first few observations. The result shows you the difference in spending between 2017 and 2018 for the first 6 customers in the dataset. Now we are going to create the percentage spending differences and round it to 2 decimal places. To round the numbers, we can use the round function in R. And we'll also then place the percentage sign using the paste function. First, I'm going to create a new variable called the percentage spending difference. As you can see, to calculate the percentage spending difference, we divided spending difference by the spending of 2017 and multiply that number by 100. And we are going to round this number to 2 decimal places. So we use the round function and use the option digits equal to 2. Then we are going to use the paste function to combine this number with the percentage sign. Now let's take a look at the first few observations. As you can see, the result shows you the percentage difference in spending. Now we are going to reduce the skewness of the income variable by using the logarithm transformation. We are going to use the log function in R for the natural logarithm transformation. And I'm going to create a new variable called the income natural log and use the log function in R to transform the income. And let's take a look at the first few observations. Compare that to the original income values. As you can see, now the income values have been transformed into log values, and by transforming the income values into its natural log values, we have squished the numbers so that the differences between these numbers become much smaller. And you can achieve a similar effect by using the square root transformation. Now to calculate a customer's age as of January 1st, 2019, we first need to convert the birth date variable into the date values and create a new variable for the January 1st, 2019 cutoff date. To convert a variable into date values, we are going to use the as.date function. Make sure that you also include the format option to specify the format of your date value. Here we're going to use %m/%d/%Y to indicate that the birth date is in the format of 2 digits for month, 2 digits for date, and 4 digits for the year. And then we are going to create a new variable called the end date to store the cutoff date of January 1st, 2019. We also use the as.date function to make sure that it is in the date format so that we can compare it with the birth date field. Also make sure that you include the format option to specify the format the date is in. If you plan to use the date value in a different format, you can search online for the different R format options for the date. In order to find out the age, we are going to use the diff time function in R to find out the number of days between the customer's birthday and January 1st, 2019. And by dividing the difference in days by 365.25, we account for the leap years by using 365.25 instead of 365 and obtain the difference in years. We're going to create a new variable called age and use the diff time function. The diff time function requires 2 parameters. By supplying the 2 dates, the function is going to produce the differences between the 2 dates in terms of the number of days. And we are going to divide this by 365.25 in order to get the number of years. If you take a look at the result, you will notice that the result also comes with decimal places. As we usually don't have decimal places in age, we need to remove the decimal places using the floor function in R. However, in order to use mathematical functions such as floor, we need to first convert this number into a number field by using the as.numeric function. And then we are ready to use the floor function to remove the decimal places. Now let's take a look at the age. Let's look at the age for the first few observations. As you can see, now the decimal portion of the age number has been removed, and so all the ages are integer numbers. Finally, we are going to use the month function to extract the month name from the birth date variable. So we are going to create a new variable called the birth month. And we use the month function in R to extract the month. If you take a look at the result, you will see that the birth months have been extracted from the data. However, they are in the format of English birth months. For example, the first record has the birth month of December. The second one has the birth month of May. It is pretty difficult to deal with these categorical or text fields in data analysis. So sometimes we want to convert these text variables or categorical variables into numbers so that we can use them more easily. So I'm going to use the match function here to convert the month names January to December to numbers from 1 to 12. We are going to match the birth month in the dataset to the month name variable, which is a built-in construct in R. Now let's take a look at the birth month field for the first few observations. Now the birth month function has created numbers that correspond to the birth month name. So to summarize, in this demonstration, we have shown you how to perform some mathematical transformation, including creating the differences, percentage differences, perform log transformation, and also to work with calendar date fields, such as converting the birth date into age and extracting the birth month from the birth date field.